everyone. So my name is Kanchan Dikshit. In previous video of Booth algorithm introduction, I have already introduced you all with Booth algorithm for multiplication process, its flow chart, the example for +7 and +3 multiplication steps, and also given you the brief of applications, its advantages, its disadvantages, right? So for this video, I'm going to give you a brief introduction about the multiplication process for a integer and a negative integer. So there are total three possible cases for both multiplications. So there was a positive multiplication with positive integer, the positive integer multiplication with negative integer, and the negative integer multiplication with negative integer. So in this example, I'm going to show you the multiplication steps according to Booth algorithm for -7 and +3. So you can take a brief for Booth multiplication steps uh, for following the algorithm of Booth. So this is here we need to give the value of multiplicand in M, the value of multiplier in Q. I have already introduced you all in previous video for this Booth multiplication flowchart. In Q minus 1 will be initialized with 0, accumulator will be initialized with 0. Here the number of bits the accumulator will be initialized completely depends on the number of bits in multiplicand. Number of bits, this is the counter. It will be treated as a counter for Booth multiplication. How many times the Booth algorithm will run, this will be completely depending on the value of M. Now, after this, we need to check out the combination, that is Q0 and Q minus 1 for every counter value. So according to this Booth algorithm, we need to go for 0, 1 combination. We need to apply plus M operation, and for 1, 0 combination, we need to go for a minus 1 operation. And after both of the operation, we need to go for arithmetic shift right for the complete value of accumulator Q and Q minus 1. If the value becomes 0, 0 or 1, 1, automatically it will be at arithmetic shift right only. The counter becomes decreased by 1, and if the counter becomes 0, you can find out the result. Okay, so I'm going to show you how to use both multiplication algorithm for -7 and +3. So -7 here, it is M. We need to find out the binary equivalent for it. So minus will be here and +7, 10. For +7, we can say 0, 1, 1, 1. This indicates that this is a positive integer, but we need to find out the 2's complement to make it a negative integer, right? So after this, we need to take first complement of it. 1's complement, that will be 1, 0, 0, 0. Then 2's complement, for this at LSB, we'll add 1. So 1, 0, 0, 1, right? This will be the value for -m. Now for Q, I can say this is +3. So it will become 0, 0, 1, 1. So in previous video also I have given you the brief about why we are taking there four digits, because these 3 digits will make it to equalize with the help of multiplicand number of bits, and this will be for the sign bit, as we are taking the sign bit in multiplicand also, right? Now, okay, so now we need to compute minus m value also. So minus m will become plus sign 10, or we can say minus minus 7, 10. It will automatically be plus 7, 10. So this is equal to 0, 1, 1, 1. This 0 indicates that it is a positive integer. Okay, so for a plus m operation, we need to add 1001 because this is the 2's complement of 7. That means this is the value of minus 7, or this is the value of m. So addition will take place for m, that will be minus 7. For minus m, we'll add plus 7. Clear? So for minus a minus m operation, we'll add 0, 0, 1, 1. Clear? Now, moving forward for the steps. The accumulator will be initialized as 0, or we can find out the value in accumulator is 0, 0, 0, 0. Clear? For Q it is 0, 0, 1, 1. Q minus will be 0 and will be 4. Operation, which operation will be performed first? So the operation will be performed, that will depend on the value of Q naught and Q minus 1. Q naught is 1, Q minus 1 is 0. So combination becomes 1, 0. That tells you that A minus M will take place. So the first operation will be performed, that will be accumulator will be updated with the value of accumulator will be added with the complement value of M. So here the value of M will be 1001 and the value of minus M is 001, sorry, 0111. Clear? And ASR, you all know that we need to shift it right. So if we shift it right, this one will be discarded. This one will be LSB now. This one will be here and 0 will be here and this 0 will be copied as MSB. So now it will be added with minus M. That will become 0, 1, 1, 1. Clear? And this will hold the same value, that is 0, 0, 1, 1. This Q minus 1 will be 0 and this N will not be updated until we perform ASR. So after this we need to perform ASR. So this 0 will be discarded. This 1 will be Q minus 1 now. This one will be Q naught now. This will be 0. This will be 0 and this 1 will be shifted to Q. And this 1 will be shifted to Q now. Now this one will become the LSB of accumulator. This one will be here. 0 will replace to 1 now and 0 will be copied. So this is the updated value now, and with the ASR, after ASR, the value of N will be decreased by 1. So here we can find out the value of Q naught and Q minus 1 is now 1, 1. So for this, we all know that we need to perform ASR directly here. So this one will be discarded. This one will be now Q minus 1, 0. ASR will be performed here. This one will be the part of Q MSP now. This will be 1. There will be 0. This will be 0 and this 0 will be copied. Clear? So this is the updated value of accumulator Q and Q minus 1 now. With the completion of ASR, we need to decrement the counter value. Now again we need to check the value of 0, 1. So the combination of 0, 1 says that the operation that will be performed, that will be A minus M. Now accumulator will be updated with this operation. The value of A plus M is 1, 0, 0, 1. Now 0, 0, 0, 1, 1, 0, 0, 1. The value will be 0, 1, 0, 1. Clear? So the value will become 1010 now. Q will not be updated. This Q minus 1 will remain same and will not be updated until we perform ASR. Now we need to perform ASR. This 1 will be discarded. 0 will be Q minus 1 now. 0 will be now Q naught. 1 will be shifted here. 1 will be shifted here. 0 will be shifted here. And 1 will be shifted here. 0 will be at the place of 1. 1 will be at the place of 0. And 1 will be copied. So this is the updated value now. Now we need to check again the value of or the combination of Q0 and Q minus 1. Because the counter value is again decreased by 1. So for the combination of 0, 0, we need to directly perform ASR here. Clear? So this will be shifted to 0 as this 0 will be discarded. This will be 1. This will be 1. This will be 0. This will become the part of Q now. 0, 1, 1. This 1 will be copied here. Clear? Now the value of Q and Q minus 1 becomes now the value of n will be updated as 0. As we find out that n is equals to 0, we can find out the result in accumulator and Q. We need to discard Q minus 1. So now the updated value is 1110, 1011. Okay, this 1 indicates that the result is negative. Clear? So if MSB is 1, we need to find out 2's complement of the result. So for 2's complement, first we need to go for 1's complement. That will be 0, 0, 0, 1, 0, 1, 0, 0, and then plus 1. So somehow the value becomes 1, 0, 1, 0, 1. And this 1, 0, 1, 0, 1 is the equivalent for 21. As we have already taken 2's complement, so we can say that the result is minus 21. Right? For the reference purpose, I have used Morris Mano, and the name of book is Computer System and Architecture. Thank you so much.